Hello everyone. Once again, welcome to my another presentation. My name is Mohammed Adam. I am a captain on the Q400 aircraft. Today I wanted to just discuss with you all the understanding behind the Vnav VTO function of the FMS of the Q400 aircraft. VTO stands for vertical 2. So let's begin this presentation. First of all, I'll present some written descriptions and an image, and then we'll end up with a video. Basically, this video is just from the software produced by Majestic for the Dash 8 Q400. Okay, in this picture, you see the path of an aircraft, the Q400 rather, which is coming in for a landing. So it's initially following a published profile on a plate, let's say for example an RNAV approach, which is shown by the red FMS track. As the aircraft descending down, at X, the air traffic controller or any other reason would warrant the aircraft to deviate from its vertical and horizontal profile. So what happens then is that the pilot will use heading mode to steer the aircraft off its published magenta track, the FMS track, and also use vertical speed mode to, for example, reduce rate of descent. This is one type of scenario. And now what the aircraft's path will look like now is a bit different to its actual published LNAV VNAV profile as shown by the FMS magenta track. Now the lateral and the vertical profiles are being controlled specifically by the pilot with adjustments to heading and vertical speed. And the aircraft in either case is following a path that takes it to waypoint A. Thereafter it makes a right hand turn to waypoint B. Let's say B is the final approach fix, and down to the landing. But as you can see that the published FMS track, the LNAV VNAV track, always would maintain, as per definitions, a 3-degree descent profile. The blue track rather does not have any specific angle. It can be steep, it can be shallow, it can be anything, because it's controlled by the pilot's input for particular headings and vertical speed for descent. Now let's move on to describe the couple of points that may lead to such a scenario. So as I said in the previous slide, when we visited the diagram, you are in the descent using the FMS LNAV and VNAV mode. You are routing to waypoint A down to B, which lines you up with the runway. Now, as I said, at X, there is a deviation from the published lateral and vertical profile, and the pilot would intervene using heading select and vertical speed. The reason could be any out of radar vectoring. Maybe the air traffic controller wants you to widen up your profile, open up rather. There can be traffic, so he wants you to move away from the traffic to avoid a particular collision. So he would say, can you steer on a heading of so and so, and then maybe reduce your vertical speed and the like. The other reason could be weather. So you are on a published LNAV VNAV mode, a proper nice 3-degree descent profile. However, ahead of you you've got some weather, so obviously you've got to go around the weather, whether you'll go left or right, or whether you'll reduce rate of descent so that maybe you just go a bit above the, let's say, some sort of cloud, and so on and so forth. So all this disturbs your actual vertical profile as well as your horizontal profile. And you'd appreciate that, because the FMS is a computer which has a database which has a program for every approach that is installed or uploaded rather in that computer, which gives you a proper 3-degree profile for the descent, all the way down to your initial fix, right down to the initial approach fix, to the final approach fix, down to the landing. So the last point here, I've said this will bring you high on profile, could be low as well, and your VPath indicator now would look like the next image which is about to come in the next slide until it disappears out of view. So let's go and see this image. So on this image, what you are seeing is that the lateral mode is heading select, the vertical mode is a vertical speed, and the speed is at minus 800 feet per minute. And what has happened now, if you can see, the blue arrow is pointing to the VPath indicator, the little magenta vertical on the vertical bar next to the EADI, and it's showing us that we are getting high. So it will continue moving down until it disappears off view because it's off scale. So that has disturbed your profile completely. If you're on the profile, you would be exactly in the middle, but right now it's showing you almost 1 dot high and going even higher as we still continue deviating on our path. So this is what's going to happen if you are going to be in heading select and vertical speed mode. Now let's move on and describe a few more features of this, and then how we can get back to a proper 3-degree path once all the restrictions have been uplifted. Okay, so now whether you are beyond waypoint A or before it, eventually you'll have to get back to your LNAV Vnav profile so that you get a smooth descent profile down to the landing. Once your restrictions from radar, traffic separation or weather has been solved, you now want to obviously get back to your 3-degree profile for the landing. Now how do we do this? Well, different aircrafts have got different mechanisms to allow you to come to the profile. Let's say if you are going to be flying the Boeing 737NG, of which I was a first officer, if you are very high, you can deploy speed brakes, you can use level change, you can use vertical speed. There are all sorts of functions there that would allow you to catch with your profile. Okay, if you are very, very high, then obviously you don't want to dive vertically. I mean, it doesn't make sense. So you may orbit and descend in the orbit until you catch up with your profile. The FMS in the Dash 8 Q400 has one very, very clever mechanism on how the aircraft can be brought onto its vertical profile if the vertical deviation is within limits, and this function is called the VTO. VTO stands for, as I mentioned in my very first introductory slide, it's called vertical 2. So it's only to do with vertical waypoints, meaning waypoints to which you are descending and they have an altitude restriction. Remember, if you are descending to a waypoint and if it does not have a vertical distance to, it will not be in the VTO list. A VTO point can only be there if there is an altitude which you have to comply when you cross that altitude. So it is a very clever way of getting you back on profile, and you must remember that Vnav will only work if LNAV is available. So in this aircraft, Vnav is dependent on LNAV. If you don't have LNAV, you will not get Vnav. So now what you want to do is to literally tell the aircraft to get you back on the 3-degree profile that was being followed by the FMS before you went heading select and vertical speed to comply with the restrictions that were mentioned. So now what I want to do is I'm going to just play a software here from the Majestic and just show you how it all works. So let's watch the video together, and also I'll talk you through what I was doing and how it all unfolds, and you just get back to your profile. It's very interesting actually. Once I got to learn about this, I was really fascinated. I was very happy actually that indeed such a mechanism exists on the FMS of a particular aircraft. I'm pretty sure other aircrafts have got similar or even better mechanisms as well. So let's go and watch a presentation. Okay, so what you see here is an aircraft which is descending to 7,000 feet. I'll keep pausing and then switching and then turning on the play again so I can talk you through nicely. What you see is we are in LNAV, Vnav path. We are descending 7,000 and we're in alt cell. And we are heading to a waypoint called Utuga. Utuga is a waypoint in Lilongwe, which is where we fly. And then you have the FMS here. This FMS isn't exactly as the one we find in the Q400 real aircraft, because this version is a bit more behind the latest versions of the what you call the majestic versions of Q400. But yet the VTO function will show you exactly what has to be shown in a nice way. So let's continue, unpause this and see what's happening. Now what you see, we've been given a restriction, so we are told to turn to a heading of 092. So we've gone heading select, and the vertical speed we have to reduce. So we're going to reduce the vertical speed to say 800 feet per minute, which is what you see. Now what you are seeing here where the cursor is that the V-path indicator is showing that we are getting high because it's going down. So it will continue to go down 1 dot until, if it continues like that on the profile, this will eventually disappear. Okay, as you can see, we're still going down. And then what happens is that we are now in a position where our vertical profile has been disturbed. So we are no longer on a 3-degree profile. The 3-degree was shown by this magenta line here, which you can see where the cursor is moving. Okay, that's what you call the FMS track. But right now we are out of the 3-degree profile. So the question now is, how do we get back to the 3 degrees? If you remember in the previous slides, we said that in order for you to have Vnav, you've got to have LNAV. So let's say now the restriction is all removed. For whatever reason we deviated from our 3-degree path, the restriction has been removed, and we want to get back onto the 3-degree path towards Utuga. So what do? We first of all have to have LNAV, and to do that we have to go direct to a waypoint, which is either where we were going or another one after that. So here what's going to happen, we are going to choose DTO. DTO is direct to, and you can see we are selecting 5, which is Utuga, and then we press enter, and then we go ahead and press nav. Then you can see LNAV has already appeared on the FMA. Then what we want to do is that we want to now create a vertical profile so we can get back onto the 3-degree vertical profile. For that you go to the Vnav page and then you select VTO. Now when you go to VTO, you're going to be given a list of options, and remember what I told you is that you only have VTO points if they have an associated altitude to which you've got to descend to. You can descend to rather. If there is no altitude on a particular waypoint, it means it's not a vertical waypoint. Okay, so that's basically what VTOs means. Okay, so now what we're going to do, we're going to continue descending to Utuga. So we're going to select we're going to select Utemi. Utemi is a final approach fix. So what I've done here, we are going to Utuga, but we are going to ask the aircraft to calculate for us the 3-degree path from Utemi. Utemi is a bit further down. It is a final approach fix of this approach. Okay, it doesn't matter which VTO point you choose. It could be the same as the DTO point, or it could be different. However, the VTO point must be further from the DTO point that you've chosen. Okay, I hope that makes sense. So there we go. We have chosen Utemi, which is the final approach fix of this approach, and then we're going to engage Vnav. So once we go and engage Vnav, there we go, and then we fly down. Once we fly down, you can see now that the path here, which was all the way down here, now it's gone here on top, which means it's telling us now we are below the path. Now if we keep the rate of descent at this low value, we are going to try catching up with the path, and you can see now this path is moving. So we are like coming underneath the vertical path until we catch this path somewhere in the center, but just before that, this Vnav armed will go into Vnav engaged in green, which means that it's telling us that you are back on the 3-degree profile that you are on. Okay, so let's wait a moment and see what happens, and in a moment you'll see Vnav path coming. There it is, Vnav path. So now you are back on the 3-degree profile. Okay, it's very easy. So that's basically how the Vnav function works. Definitely there will be another one example coming just now. So here we go. So everything is back to how it was. You can see LNAV Vnav path, okay, after the deviation. So we haven't lost anything. We just told the aircraft to get back onto its vertical profile. Right, now what's going to happen, we're going to, let's say, disturb the vertical profile again. So we're going to go vertical speed, and I will reduce the vertical speed to around minus 400 to minus 500 feet per minute, as you can see what's happening there. All right, and now look what happens to this V-path indicator. Because we've reduced our vertical speed, means we're going to come higher on the profile. Okay, and you can see that this vertical profile now is going to go lower. It means that we are getting higher, and once we are done with that maneuver, for whatever reason we did it, we want to get back onto the 3-degree profile. So again, you can see we are getting higher and higher and higher, and if it continues like that, this will be disappearing out of view. Okay, now we're going to go and do the VTO function, and on this FMS, mind you, as I said, this FMS has got it's not the same as the one in the Q400, the actual one. So here I had to cancel the whole Vnav, which I did, as you saw, and now we're going to reprogram once we cancel the Vnav, it means that it brings the VTO function only, so it can give us the options we want to descend to. So you can even see that the VPath bar here is gone. So I've cancelled the Vnav. That's just a procedure for this particular software, and now you can see now that it's bought us the VTO options. So it's our choice. We can VTO to Utuga, we can VTO to Utvag, we can VTO to Utemi. All of these have got published altitudes which are lower. Okay, now you can see what's happening here on the MFD. We were going to Utuga, then to Utvag. Okay, initial approach fix is Utuga, initial fix is Utvag, and the final approach fix is Utemi, from where we start 2 miles before that we start configuring, and down to the landing all the way onto the runway. So we're going to choose Utemi, I guess, again. So let's choose Utemi, which is number 5. There it is. And then we press enter. Once we press enter, and then we go and press Vnav. Don't forget to press the Vnav. And then you see what happens here. We get Vnav again armed, and again it's telling us that now we are below the profile from the new calculations, and if we keep the rate of descent just the way it is, we'll definitely catch up. If you increase this, you will be getting lower and lower and lower, and you don't want to do that because you'll be ending up near the ground. So there we go. We are now approaching the profile, the 3-degree profile. The aircraft is coming from underneath, trying to catch up with the 3-degree profile, and once it catches up, the Vnav armed is going to go into Vnav path. There it is, and here we go. We are now into LNAV and Vnav path, and that's basically how this whole Vnav VTO function works. I hope you understand and you practice it, and it's not that difficult at all. It's very nice to know it. Thank you very much for this. I do hope that you have learned something, and do be kind enough to subscribe to this channel, and as we go along I'll be making some more practical videos for you to consider. Thank you very much, and enjoy.